Hello, my learned colleagues. In this video, we're going to answer a past question from IGCSE, February-March 2020, paper 3 in the core curriculum. And we are looking at question number 7. The question focuses on bearing and distance and how to represent statistical data in a pie chart. Let me show you the question I'm talking about, the question paper, so that if you want to follow along, you can do so. This is paper 3, February-March 2020, and I'm looking at paper 32 to be precise. That is the code number for the paper. And the question is question 7. It says, the scale drawing shows the position of a rock R and a statue S on a map. The scale is 1 centimeter, represents 6 meters. This is the two reference point R and S, which is a rock and a statue. The question says, work out the actual distance between R and S. To get the distance between R and S, we will measure with a ruler from point R to point S. With my ruler placed 0 mark on R, I'll measure down to X. Okay, so based on what I'm seeing here, that is 9 centimeters there. So the distance between R and S on paper is 9 centimeters. But the question wants us to get the actual distance. What I mean by actual distance is what will be the distance on ground. This is paper distance, which is 9 centimeters. So to get the ground distance, we need to convert that 9 centimeters based on our scale, which is 1 centimeter to 6 meters. So if 1 centimeter is 6 meters, what would 9 centimeters be? Using simple proportion, we do this. 1 centimeter is equal to what? 6 centimeters, 6 meters rather. What would 9 centimeters be? Let it be X. So if that is the case, using simple proportion, we cross multiply. 1 times S is X. So S equal to 9 times 6. 9 times 6, which is 36. So the actual distance is 36 meters because 1 centimeter is 6 meters. Therefore, 9 centimeters will be 9 times 6 meters. And 9 times 6 is not 36. 9 times 6 should be 54. So 54 is the answer there. So the actual distance is 54 meters. 54 meters. That is the first part of the question covered. And the second part says a flagpole F is on a bearing of 164 from S. Work out the bearing of S from F. Okay, let's first of all locate that flagpole based on the information given to us there, which is the bearing of 164 degrees. How can we get that? Our reference point is point S. It's a 164 degree from S. So with my protractor placed on point X, I will measure an angle of 164. And when doing that, recall that if you have watched my previous lesson, when you want to measure an angle with a protractor, this baseline here on the protractor, this horizontal line on the protractor must rest on your reference line. My reference line here is this line. So I'll make sure that my baseline on the protractor rests on it. And then the reference point is this point S. I'll make sure that where the baseline of the protractor meets the angle 90 line, this vertical line here, where they meet, this very point here must also meet or rest on my reference point. So I will do that here. Place it carefully so that exactly That is it there. So I'll measure 164. Is it 164? Yep. The angle is 164. And here is my 164. Right there. Let me place it so you see it clearly. This is 160. 164 is right here. I'll put a mark there. That is bearing of 164 from point S. Then connect that point with point S. Place my ruler in a way that I can get that accurately. Okay. I join that with a line. That is a bearing of 164 from S. S 164 is right there. 164 degree. Okay. And then it says work out the bearing of S from F. Okay, let's locate point S, point F first. This is point F. I want us to get the bearing of F from S. How can we do that? To get the bearing of F from S, let's draw a reference line, a cardinal line, or cardinal point. I rule a straight or a vertical line. Make sure that my ruler is well placed. Okay, this is my reference line. Remember, when measuring bearing usually is from north in clockwise direction. So the question is asking us to get this angle all the way from this side to this side. That will be the bearing of excuse me, S from F. And this angle, looking at it, is more than what we can measure with a protractor. So how can we get that angle? Now, we apply our knowledge of geometry. If this angle here is 164, this angle is 164, we know that alternate angles are equal. So let me clean this line so I can explain what I want to talk about. This line that I drew here, this is my vertical line, and this line here, if I extend both of them, there will be a parallel, they are parallel line. They are parallel line to each other. And whenever there are parallel line, if any line crosses the parallel line, that line is a transversal. And when a transversal crosses parallel lines, two types of angles are formed, basically, either alternate or corresponding angles. You can also have a co-interior angles, but my focus here is on alternate angle. This angle here and this angle here are alternate to each other. So from here all the way like this is also 164. All right, 164 there, 164. And recall, want to measure this angle like this, all this way down to this place. So if from here to here is 164, we already know that this vertical line here is a straight line, of course. An angle on a straight line here is 180 degrees. So to get this angle all the way like this to this side, I will add 180 to 164. So 180 added to 164 will give us that will be, let me do my calculation here. I don't have a calculator with me. So 180 plus 164, that is 4 right there. 8 plus 6 is 4 again, that is 14. Right, 4 carry 1, that is 344. 344 is this angle like this. So the bearing of S from F is 344. let's write it here. 344 degree is the bearing of S from F. Now the question went further again. It says Ishan, or whatever that name is, I think I murdered the name. Ishan uses the map to find some treasure T. T is on a bearing of 76 degree from R and on a bearing of 337 from S. Mark the position of T on the map. Okay, T, that is the treasure, is on a bearing of 76 from R. So let's locate that first. 76 from R. Again, I'll place my protractor on the reference point where these two lines meet. The vertical and the baseline where they meet should be on my reference point, and the baseline should be on this reference line. And then measure 76 right there. Here is my 76. I'll put a mark there. 76. I'll join that point to point R. Join the point to point R. Okay, that is it right there. Now, that is 76 from R, bearing of 76 from R, and on a bearing of 337 from S. So we need to get that now. 337 from S. Here is our S, so we need to get the bearing of 337 from S. Remember, we measure bearing from north. So I'm going to get 337 all the way like this. To do that, let me draw some cardinal point here. Let me draw some cardinal point. I have this as my horizontal line and this as my vertical line. I'm using freehand, it doesn't matter since I'm going to measure with protractor. Now, 337, there's no way I can use protractor to measure that because my protractor is 180 degree maximum. So how can I measure 337? I will use simple logic. We know that this cardinal point or this plane divided into 4, each of the quadrants is 90 degree, 90, 90, 90, and 90. 90 plus 90 plus 90, that is in 4 places, is 360 degree angle at a point. So if from here all the way to this place is 360 degree, how can I get 337 from that? I'll first of all subtract 337 from 360 degree. Once I do that, the remaining one is what I will use my protractor to measure. So 360 rather minus 337 is 23. So I will measure 23, but this time around I'm going to go in anti-clockwise direction because the 337 is coming all the way like this down to this place, something like that. So measure 23 rather, 23 from this point and go in anti-clockwise direction to give you that required angle. So 23, here is 20. Oh, my hand is blocking it. 23, I'll come this way. This is 23 somewhere here. Look at this, there's 20 there. So is this one I'm reading? I'm reading the lower because I'm going in anti-clockwise direction. If I'm going in the anti-clockwise direction, you read the base, this measurement on the inside. So I have 23 somewhere here. Here's my 23 degree. put a mark there, and then connect that point to point S. Okay, let me connect that. So from here, based on what we have done, from here to here is 23, and the bearing you are looking for is 337 here in the question. So from here like this down to this place is your 337 degree, which we got by subtracting 337 from 360 to get this 23 here. So measure 23, the remaining one from this side gives you your 337. So now the question says we should mark the position of T on the map. So where the first line here, remember the question say the point is on a bearing of 76 from R and on a bearing of 337 from S. So these two lines, the bearing of 76 from R and the bearing of 337 from S, meet at this point. So where they meet is the position of T. So indicate that with T. That is the point there. Based on the information given to us, that's the treasure map or treasure, whatever they call it, the T. Okay, that is that for that part of the question. Then the B part of the question says the treasure, that is the treasure that Ishan or whatever the name is, got in there. Ishan uses the map to find some treasure T. T is on a bearing of 76 from R and on a bearing of 337 from S. Mark the position of T on the map rather. So what is that treasure? The question went further to say that the treasure is a bag of coins. The coins are made from 3 different metals. Question 1 say complete the table, and 2 say complete the pie chart. These are the 3 different metals that made up the treasure. Copper is 70%, zinc is 20%, tin is 10%. So we have to calculate the pie chart sector angle. Remember that to get the sector angle of a pie chart, you divide the value of that very quantity you want to get the sector angle, divide the value of it by the total value of all the quantity, then multiply by 360 degrees. We multiply by 360 because the total angle in a circle is 360 degrees. But the values here are given in percentage. Copper is 70%. What is percentage? Percentage means over 100 or out of 100. So to get the sector angle for copper, that will be 70 divided by 100 times the angle in a circle, which is 360 degrees. So let's use a calculator to do that. 70 times 360 is 25,200 divided by 100. That is 252. So 252 is the sector angle for copper, 252 degrees. Then the sector angle for zinc will be 20 over 100 because zinc is 20%. So 20 over 100 times 360 degrees. Again, let me use a calculator there. 20 divided by 100. 72 degrees or so. Yes, 72. So the sector angle for tin or zinc rather is 72 degrees. And lastly, tin is 10%. The sector angle there will be 10 divided by 100 times 360 degree, and that is 36. Degree is the sector angle for 10. To confirm whether those angles are correct, we add up all these values here, 252, 72, and 36. If they add up to 360 degrees, that means the sector angles are correct. If they are less than or more than, it means they are not correct, because we are drawing a pie chart. The total angle should be 360 degrees. So let me add up those numbers and see. 252, 360. So our angle is correct. Now, the next thing is to draw the pie chart. They have already given us a reference point here. So we use that line and the point as a reference. Place your protractor in a way that the baseline is on the line already drawn there, and where the baseline meets with the 90 degree is on the point. The first angle there is 252 degrees. We can't get that with a protractor, so I will measure the smaller angles first. The remaining one rather will give us the 252. So the first angle here, I'm ignoring the 252. The first one will be 72. So 72 is right here. I have my 72 right there. Put a mark. Then with my ruler, I will connect that mark to the reference or to the center of the circle. That is for zinc. Let me put the angle 72%. Let me put it 72% zinc. Then the next one is tin, which is 36%. Now, the line I just drew now becomes my reference line. I place my protractor in a way that the baseline of the protractor rests on the line. And where the baseline meets the vertical line must be on the reference point, the center of the circle. So I want to get 36 degrees, which is the sector angle for tin. 36. My hand is blocking the camera, so let me use the other hand. 36 is right there. This is 30 here, so 36 is right there. Put a mark there, and then draw a line from there okay, that is it. 36 degrees for 10. 36 degrees, that is 10. So this remaining one is 252 degrees, which is copper. 252 degrees, 252, that is copper. And that is the end of the question. A beautiful one there. I hope you find it very useful. If you do, don't forget to click the like button and share it with your friend. Thank you.